We're going to continue our focus today on the angles of our circles. We're going to expand what we know to include our chords, secants, and our tangents. Let's review what we know so far about the angles in circles. We have our central angles. Remember where the vertex is in the center, and the central angles equal their intercepted arc. And we have our inscribed angles. Draw one here, and remember that inscribed angles have their vertex on the circumference. And remember, in this case, your angle, your inscribed angle equals half of its intercepted arc. Well, if we take a look here at our inscribed angle, let's go down to our two new pictures we have here. We have a circle here where we have a chord AB and a tangent CB. Notice, though, that they intersect and we form the angle ABC. Angle ABC has its vertex on the circumference just like an inscribed angle does. And look at your circle in here. We have a secant and a tangent, but again, that vertex where they intersect, that vertex is on the circumference. So in these two cases, you go back to what you know about inscribed angles and you use your same formula. The angle ABC here will be half of its intercepted arc of AB. And the same would be true over here. Now let's take a look at our next picture here. In this picture, you see that you have an intersection and you have some angles now that are inside your circle. Notice that they are not in the center. In this case, what we do is, in order to find the measure of angle 1, we would look at the intercepted arcs. In this case, we have arc AD and we have arc CB. To find the measure of that angle inside, we would take those two arcs, add them together, and divide by 2. Alright, well, what happens when the angle is on the outside? So we have 3 cases here where your angle is on the outside. This is a secant and a tangent. This is 2 tangents. And this one is 2 secants. In each of these cases, we have that the angle is on the outside. So in this case, what we would do, we would still look at the intercepted arcs. In this one, on our first one, we have arc AC and have arc XC. Here we have PR arc, and then over here we have PQR, and over here we have arc XY and arc WZ. In all 3 of these cases, with the vertex or the angle being on the outside, we will follow the formula where we take the small intercepted arc and subtract it from the larger one, and your formula will look like this. Alright, let's look at some examples. Our first example here, you're going to focus on where the vertex is of the angle. In this case, the angle is on the is on the circumference. So in that case, we refer back to what we know about inscribed angles, that the measure of your angle will be half of its intercepted arc. So if we look at our intercepted arc here, we have 220. So we're going to take that 220, we're going to divide it by 2, and we get the measure of our angle in this case would be 110. So x is equal to 110. Our second example, we focus on where that vertex is. It's inside the circle. So we use our formula where we take our 2 intercepted arcs and we add them together. So we have the intercepted arc of 106 and 174. We add those together, and when we add those together, we get 280. And then we have to divide that by 2, and we get the fact that our x, or our angle, is 140 degrees. Take a look at our third example down here. We focus on the fact that the angle is on the outside. So when the angle is on the outside, we still look at the intersected arcs, but in this case, we always subtract the smaller from the larger. In this case, our smaller one has a measurement of x, and our larger one has a measurement of 200. It actually gave us the angle itself, and now we're going to work backwards and find the measure of the smaller arc. We're still going to use our formula. So we take our larger arc minus our smaller arc divided by 2, and that gives us the angle measurement of 72. So we've got to get rid of this 2 here, so you would want to multiply both sides by 2. So those would cancel. So we would have our 200 minus x here equal to 72 times 2, or 144. We need to solve that for x, so we would move our 200 over as a negative 200, giving us negative x here equal to negative 56. Divide out that negative 1, and we get that x equals 56. So your smaller arc is 56. And think about it, it would have not made sense for your arc to be a negative, right? Because we do not measure length as negatives. Let's come over here to our next example. Again, in this case, the vertex or your angle is on the outside. So we will refer back to this formula. So we're going to take our larger arc here minus our smaller arc of 92, and that will give us our divided by 2, and that will give us our angle. Well, here's a problem. They did not give us what this angle measurement was, but you know that the total measurement is 360, so you're going to take your 92, subtract it from 360, and you get your arc. So we're going to work on the fact that we have our larger arc of 268. Now, we're going to use our formula. We're going to subtract. So we're going to subtract the 92 from the 268. That would give us a measurement of 176. We've got to divide that by 2, and we get our angle, or our x, to equal 88 degrees. One more example, we're going to bring in our algebra. For this one, we're going to focus on that angle. Where is the vertex? The vertex is on the circumference. So remember then, we refer back to what we do with inscribed angles. This 5x is going to is half of its intercepted arc. So we're going to have to set up an equation because we can't find the measure of angle CBD until we know what x is. So let's think about what we're going to do. I'm going to set up my equation. So I have over here, I have my 5x and I have my 9x plus 20. You notice that they're not equal to each other because they're not, right? Because your 5x is only half of your 9x plus 20. So if I want to make a true equation, I've got to fix what I have here. Since I know that this is half, I know that it will take 2 of my 5x's to equal my 9x plus 20. So I'll adjust my equation, and I'll take 2 times my 5x. Now I know that I have a true equation. And I'll multiply the 2 times the 5x. So I have 10x equal to my 9x plus 20. I'll continue solving it. I'll move my 9x over as a negative 9x. And that would leave me with 1x over here equal to my 20. So now I can take what my x is, I can put it back into my equation or my angle. And if I take 5 times 20, I get 100, and I have found my angle. So feel free to go back and rewatch the video. And after you do that, then work on the problems that we have given you.